that you notice in this picture? Or what do you think this is a picture of? Yeah?
Stars. Stars. Some of them are bigger and some of them are smaller.
Yeah? What else do you notice?
Some of them are brighter than the other ones.
Some of them are brighter than the other ones. So which ones are brighter?
The big.
Do you want to maybe point to which ones you're noticing that are brighter? You want to point?
Yeah.
The bigger ones
The
look brighter.
bigger
That
one.
big one is brighter. That one's brighter, maybe. What else? Maybe that one.
That one.
Yeah.
Maybe. The bigger ones.
Okay. Which ones are less bright?
The smaller ones.
The
Smaller ones. They look smaller, huh? All the little ones around. Yeah? Alright. So I have a question. What do you think makes a star brighter, a star appear brighter or less bright? Just think about it. Maybe make a prediction in your mind.
That one looks like it's closer. So when it's closer to you.
That one your prediction? Might be
Or
closer.
it's just bigger.
Or maybe it's just bigger. What do you think, Ivy?
I'm thinking maybe the destination in space, how far away they are, and like if like how big they are, they're just brighter than other stars. Like if you were to see that blue one, it might be like brighter than that one.
Oh, that's a good idea. Betsy, did you hear what they said? Do you agree? Do you disagree?
I agree with what Annie said, though, like, if they're farther away, they're less bright.
All right, we are going to do an activity with some flashlights
Love flashlights.
that's gonna demonstrate apparent brightness of stars, how bright stars appear. Okay, I need 2 volunteers, Ivy and Annie. You're each gonna get a flashlight. But before I give you these flashlights, I want you to look at them. What do you think? Do you think these are the same kind of flashlight? I mean, they're different colors, but
They're not the same.
they're not the same.
No?
They're
That
the
one's
same.
blue and that one's red.
Okay, but aside from their color, what do you think?
I think they're the same.
Do they look about the same to you?
Yeah, exactly.
Yeah? And guess what? I just put new batteries in these flashlights, so they should be exactly the same. Alright, so Ivy, you're gonna get a flashlight. Annie, you're gonna get a flashlight. I'm gonna turn off the light. Okay. I have 2 dots here. Oh, don't turn your flashlight on yet. I have 2 dots here that they're the same distance away from the whiteboard. I want you to each stand on one of these dots. Turn on your flashlights. And Betsy, you might want to stand up and look at this. And just tell me, what are you noticing about what's happening here? What do you see? Just say what you're looking at.
A light. It's like big.
The light
same
is
size.
big. What else? They're about the same size, it looks like.
It's kind of bright.
It's bright. Okay. Now if I have, let's turn your flashlights off. Have Ivy come and stand on this dot over here. Now turn your flashlights on again. Now what do you notice?
Mine's way brighter than hers.
Yeah?
Mm-hmm.
You think so?
Yeah.
Do you guys agree?
Yeah.
Hers looks brighter. So, what did you notice about what Ivy did and what happened to the light of her flashlight?
She got farther away.
It got farther away. But did that change her flashlight? When she walked away from the whiteboard, did the flashlight's ability to make light change at all?
No, it
No.
just
No, it stayed the same.
how far it had to travel.
But which flashlight do you think is brighter?
They both
They're
have.
the same.
No,
They're the same. But which one looks brighter?
The closer one.
Annie's does. And why is that, Betsy?
Because it's closer.
Because it's closer. See, we can try it again. Turn off your flashlights. If Ivy comes back to her dot,
Wait.
and Annie moves back to the blue dot, and you turn them on again.
Now mine's bright.
Did Annie's flashlight change?
No.
No.
Well, like it changed
So why does it look-
brightness, but
Why does it look different?
because it's farther away.
It's farther away. All right. If you could turn off your flashlight. I want you to think about what this can tell us about the brightness of stars. You can sit back down. All right. So why do some stars appear brighter than others? But before we talk about that, how do you think we measure the brightness of stars?
With a measuring tape.
By
With a
compar-
measuring tape. You sure about that?
No.
No.
By looking at them next to each other.
Looking at them next to each other? That's kind of like what we did here, huh? When we had Annie stand here and Ivy stand here and their flashlights were the same distance away from the whiteboard. Yeah.
Yeah.
Totally. That is their brightness when you're holding them at from the same distance away is what we call absolute magnitude. Magnitude is the scientific word that they use to talk about the brightness of stars, how bright a star is. So absolute magnitude is how bright a star would be if it was viewed from the same distance. And the distance that scientists use, we used, when we used our flashlights as stars, we used these dots. The distance that scientists use is 32.58 light years away from the Earth. So we could pretend that these dots were 32.58 light years away from the whiteboard. And when we shine our flashlights, the brightness that appears on the whiteboard would be the absolute magnitude of our flashlight stars. What about when we had Annie stay here and Ivy move to that dot?
It was
Did the brightness look the same?
No.
No. So that's actually a different measurement that they use. It's called apparent brightness or apparent magnitude. How bright it appears. So how do you think they find out the apparent brightness?
maybe they measure it from Earth.
Yeah, it's distance away affects how bright it is. So it's how bright a star appears when viewed from Earth. And like we look at this picture, these stars, are they all the same distance from Earth? Like, are they all lined up in a line like we had here away from Earth?
No.
No.
No, they're spread out all across the universe. And that's why some of them appear brighter than others. That's their apparent brightness. So the brightness of stars that have the same absolute brightness or same absolute magnitude can be different. Just like our flashlights, they're the same, but they appear different when they were from different distances from the Earth. So let's think about what's the brightest star in our solar system?
The sun.
The sun.
The solar system?
The sun.
Yeah.
Mm.
So, like, you're right, because when the sun is out during the day, can you see any of the other stars in the sky? No, because the sun is so bright. So why do you think the sun is so bright? Why do you think it looks so bright to us? It appears so bright.
Because it's the closest.
Yeah, did you hear what she said? Because it's the closest one. The closest to what?
Earth.
The closest to Earth. That's right. So the difference And the apparent brightness of the sun and all the rest of the stars in the galaxy is because of its relative distance to Earth, how far away